Okay, continuing from the last class, what it has been covered. So today we are discussing the remaining part of this lexical analysis. Okay, so first we will see the advantages of separating analysis and parsing. Okay, sir, the advantages of separating the analysis and the parsing phases. The one first advantage is simplicity of design is the most important consideration. Okay, so what this separation of lexical and synthetic analysis often allow us to simplify at least one of these tasks. For example, here suppose if the lexical analyzer is assigned the task of separating the white spaces and comments in the source program, once again that parser is not concerned with the white spaces and the comment lines which are occurring in the source program, because the elimination of those has been already done by a lexical analysis phase. That is one of the advantage. Then the compiler efficiency is improved, okay, because the separation of the task separately for the lexical analysis and the syntactical analysis, what we call the parser, the efficiency of the compiler is going to improve. The efficiency, it might be with respect to the speed, okay, the size of the code, what it is going to be generated. Okay, then the last advantage is compiler portability enhanced. Okay, in this case input device specific peculiarities can be restricted to the lexical analyzer. Okay, the input device specific peculiarities can be restricted to the lexical analyzer. That means what? The source code is going to be concerned with the input devices which are going to be used for feeding the input to the compiler. The parser will not come into the picture when it is going to interact with the type of the input device which is going to be used for in order to give a input to the compiler. Okay, so here the input device capacities will be handled by lexical analyzer, not by a parser. So that's why it is going to increase the portability of the compiler. Okay, so these are the advantages of separating the lexical analysis and parsing. Okay, the three different attributes that we are going to discuss under this lexical analysis is the token. The first one is a token. So this token is nothing but, the first one is a token. It is nothing but it is a pair consisting of token name and an optional attribute value. Okay, it is a pair consisting of token name and optional attribute value. Token name is an abstract symbol. Token name, it is nothing but an abstract symbol representing a kind of lexical unit. Okay. Example, a particular keyword or a sequence of input characters denoting an identifier. Okay. So generally the identifiers, those might be the keywords or sequence of the characters. So those will call it as what? A token. And the token generally it is having a keyword associated with the value which is assigned to that. Then a pattern. A pattern is nothing but the description of the form that the lexemes of a token may take. Okay, so that is nothing but the description of the token. That a pattern is a description of the form that takes the lexemes of a that the lexemes of a token may take. That is nothing but what? The descriptions of the token, generally we'll call it as a pattern. And then the lexeme, it is nothing but what? A sequence of characters in the source program. That is nothing but the sequence of the characters in the source program that matches the pattern for a token, and is identified by the lexical analyzer as an instance of that token. So generally it is nothing but what? The sequence of character which is matches with what? The pattern, and generally it is identified by lexical analyzer as the instance of that token. Generally lexeme is nothing but what? That instance of that token. Okay, so we'll see now the examples of these tokens, descriptions and simple lexemes. Okay, so now this is nothing but what? The token, the pattern nothing but the informal description. The lexemes is what? The description sequence of characters that matches for this description. Okay, now for example, the token if. Okay, the informal description of this we can call it as what? Characters I comma s. The associated simple lexeme for it is if. Similarly, if the token, generally it is a keyword, as you know, right, in the C program and all. If you consider else is the keyword, that is nothing but what? Token. What is the informal description for that? Characters E comma L comma S comma E. The lexemes for it is what? Else. Similarly, if the token, if it is a comparison, these operators might be what? Lesser than or greater than, or lesser than or equal to, or greater than or equal to or not equal to. The lexemes for this be what? Lesser than or equal to, not equal to, greater than or equal to, like that. Then similarly, if the token is a number, this informal description for this is what? Any numeric constant. Okay, and the simple lexemes might be for that 3.14, 1.9, or 6.0, 2.3, or 2.14, or some 6.002, anything like that. Okay, so this is nothing but the examples for what? The tokens, patterns, and the associated lexemes for that. Okay, so these lexical errors, these are nothing but associated with what the syntax of the language. As you write, if the semicolon has been missed, if the keywords has been misspelled and all. Okay, so that time the lexical analyzer should have capability to identify the errors which are occurred in the source program. Okay, so now suppose for example, this the if has been written as a 5. Okay, so in this case, at the first time in the lexical analyzer part of the compiler encounter this keyword, it is difficult for it to identify. The reason, the ID has been associated for this. Okay, so in order to recover from the errors which are occurring in this, the technique has been used, and that technique is nothing but what? The error recovery strategy. Okay, the technique which is used for recovering from the errors is error recovery strategy, where error recovery strategy, what it is going to be used is a panic mode. Okay, panic mode recovery, where it deletes successive characters from the remaining input. Okay, it will delete the successive characters from the remaining input until the lexical analyzer can find a well formed token at the beginning of what input is left. Okay, it will keep on deleting the successive characters till it will find a correct input for that source programming language. Okay, so this technique we will call it as what? A panic mode recovery. Okay. Okay, sir, this another one is that the recovery strategy what we have seen. The other possible error recovery actions or the strategies which are available are, it has to delete one characters from the remaining input, delete one character from the remaining input. The second might be what? Insert a missing character into the remaining input, insert the missing character into the remaining input, replace a character by another character, replace a character by another character, and transpose two adjacent characters. Transpose two adjacent characters. These are the error recovery actions which are available. Okay, so this specification of tokens generally it is done by using regular expressions. Okay, so in order to complete these regular expressions, so these are the important attributes that we need to be considered. This is nothing but the strings and the languages. Okay, an alphabet is any finite set of symbols. The example for it is what? The set of letters, set of digits, punctuation marks, anything. Okay, right, the letters, say for A to Z, we can call it as what? Alphabet. Similarly, the string, it is nothing but what? A string over an alphabet is nothing but what? Finite set of sequence of symbols drawn from that alphabet. Similarly, a string over a digits is nothing but what? Finite sequence of symbols that are drawn from that digits. Okay, and generally the length of the string S is denoted by what? This. Okay, for example, the banana is a string and that length of the string is what? 6. Then similarly the language, it is nothing but what? Language is nothing but any countable set of strings over some fixed alphabet. It is nothing but what? Any countable set of strings, it is any countable set of strings over some fixed alphabet. Okay, so these the symbols we need to consider. This epsilon, this is nothing but denoting the empty strings and all. Okay. The operations which are possible on the certain languages are union, concatenation, clean and positive closure of L. Okay. In case of this positive closure of L, positive closure of L. Now suppose for example the union of two languages L and M. Okay, it will be denoted as L union of M. Okay, here the outcome of this is that is S. The new set of language what it is going to generate is the S. In that case S is in L or S is in M. Okay, any set of symbols which are occurring either in a language L or any set of symbol which are occurring in M will be considered as a part of a S. Similarly, concatenation of LM, this will be denoted as LM. Okay, and that output what it is generated or the definition or the notation will be what? ST, in which S is in L and T is in M. Okay, compulsorily S has to be from L and T is from M. Then similarly clean closure of L. Okay, in the clean closure of L it will be considered as L star, which is equal to nothing but union of I equal to 0 to infinite. Okay, it might consisting of what? 0 or any number of characters that will be defined as what? L of I. Then similarly positive closure of L, that is nothing but L plus, which is equal to U equal to I or I equal to 1 to infinite. That is, it should consider at least one character from the language. Here it will consider either empty characters or many number of characters. Here it will consider at least one or more number of characters from the language L. Okay, so now for example, okay, we'll just say Now say for example, if L is consisting of set of alphabets A to Z in caps and A to Z in a small letters, then D is consisting of digits from 0 to 9, okay, then L union of this D, okay, is resulting into what? A set of letters and digits that is nothing but it consisting of 62 strings of length 1, okay. Then that is A to B Z, A to B Z, then digits from 0 to 9, okay. Then similarly LD, a set of 520 strings of length 2, LD, that is means what? It should have the alphabets, okay, and the characters which are there in which are there in the language L as well as in the D, that is nothing but each consisting of letters followed by digit. Now say for example, it might be like this, A1, A2, so on. So totally 520 strings will be obtained. Then L of 4, that is L of 4, it is nothing but what? Positive closure of L. This is nothing but what? It is nothing but set of all 4 letter strings. Okay, it is set of all 4 letter strings. Okay. Okay, so this is regarding the operations which are possible on the languages. Okay, so this generally, as you know, these regular expressions, these are nothing but some patterns which is used for describing all the languages. Okay, so generally these regular expressions are nothing but the patterns which are generally used for describing all the languages that can be built from the operators applied to the symbols of some alphabet. Okay, so generally this is used for regular expressions, generally used for describing all the languages, and these languages can be built from what? The operators. It might be what? The operators plus, minus, okay, which can be applied to symbols of some alphabet. These symbols of some alphabets means, if you consider the set of alphabets, from A to Z in capital, or we can consider set of alphabets in a smaller case from A to Z. Similarly, you can consider symbols as a set of digits from 0 to 9. Okay, and these languages can be derived from the set of alphabets. Okay, and these regular expressions are used for describing these languages, and these languages can be built by using these symbols which are belonging to some alphabets. Okay, so for example, suppose if we have a set of symbols like this, then now for example, if it is nothing but the sequence of symbols, okay, and that's are going to generate, and as you are aware, this regular expression is for describing the language. For example, the regular expression A or B denotes the language A or B. Similarly, if the regular expression opening parenthesis A or B, close, once again opening parenthesis A or B, close the parenthesis, denotes the languages AA, AB, BA or BB. Then similarly, regular expression A star denotes, it is a sequence of symbols. It might consisting of the empty symbols, 1 alphabet, 2 alphabet, 3 alphabet, and so on. So this is nothing but the meaning of this denotes, it is consisting of empty symbol or infinite number of symbols of alphabet A. Okay, we will stop here, and in the next class we will see the remaining part of this lexical analysis.